Good evening everyone. As you know, today we are going to discuss important questions from the gate perspective. But if you have logged in or you have come to the YouTube thinking that the questions that I am going to tell you, the same questions are going to appear as it is with the same data, then you know that the probability is just like finding a needle in a haystack. Why I am saying so? Because every year gate do some kind of changes. But what we can prepare is the topics, the important topics that they can ask. For example, nodal analysis is important from the gate perspective. Sir, do they ask a lot of questions from that? Yes, they have asked a lot of time those kind of questions from the nodal analysis, but important thing is that even if they do not ask the question directly for nodal, but nodal will be getting utilized somewhere in some other form of the question. For example, you are solving a Thevenin question, you need nodal. Suppose you are solving a transient question and you want to find the final value or something else, again you need the nodal analysis method or technique. So that's why nodal is important. So what I'm trying to tell you is that I'm going to cover important concepts which are important from the gate perspective. Second thing, I'm not going to pick very easy questions which are 1 marks questions, because if you are over here, I know you must have attended the classes or you will be having a little bit of background of the subject. So 1 marks question are really very easy which you can handle. For example, nodal question, 1 marks question will be very easy, neither model 2 nor model 3. It will be a model 1 question with the easy calculation, just 1 or 2 equations, that's it, you will get your answer. But when it comes to 2 marks questions, they will try to make something different. They will try to test you on the concept. So whatever time we have, we will try to cover important questions. Let's see how many topics we will be able to touch, because it will all be dependent on that. So let's see. And one more thing, I won't be giving you the options. My task is not to give you A, B, C and D option and tell you that this option is correct. That you can do on your own. That much I hope we have studied, and you must have studied. You can do that on your own. Secondly, you always have a kind of a doubt, and you always want to know that sir, क्या तुक्का मार दें exam में? Means can we go with the guess in the examination if we are having I have eliminated 2 options and I'm left with only 2 options. The probability is 0.5, 0.5. Should I go with that, because that's the highest probability that I'll be having for the guesswork in the examination? If you ask me personally, my answer will be no. In the GATE exam, we cannot take the liberty for going for the guesswork. Had it been engineering services, in that we can wear, how that's a different story. We are not talking about that, because GATE exam is only 2 to 3 days from now. So we won't be talking about that. But thing is that I'll advise you to not go for the guesswork. What you can do, for example, you are stuck with the 2 options. You are having option, suppose A and option D, B and C you have already eliminated. Now you're stuck with A and D option, and if it's not MSQ obviously. Then what you can do, you can go for the units and dimensions. Check the units of, if the variables are unknown variables, check the units of those variables, whether whatever he has asked, the units are satisfying or not. That way you can check. You can see what they are trying to ask you. Suppose he has asked you VTH and RTH. In all the 4 options, the VTH is different and RTH is same. Go for the VTH calculation straightforward. These kind of things you can do on your own. We have talked about these things in the class in great detail also. So I won't be writing all the options and dealing with all those kind of things. We'll be seeing good questions. So let's start with good questions without wasting time. So the first question that I'm going to deal with is a nodal analysis question. So what's so special about this question? We know what is nodal analysis. The special about this question is that this question will be covering model 2, model 3, and obviously if model 2 and model 3 are getting covered, model 1 is also going to get covered. So that's why I've picked this question. Moreover, you always have this kind of a doubt, so if a dependent source will be present, dependent voltage source I'm talking about, will be present in between 2 non-reference nodes, will that be contributing towards a supernode? That will also get clarified in this. And moreover, I'll take 2 voltage source back to back in connected between the non-reference nodes. So let's see the question what I'm talking about. And one more thing, sorry, before I start, one more thing. Whenever I give you a question, suppose I give you a pause for 30 seconds or 15 seconds, quickly try to think how you would have solved this question. Solve नहीं करना है जल्दी because इतना time नहीं है हमारे पास. मैं बस देख के 15 सेकंड 10 सेकंड का पॉज दूंगा ताकि आप क्वेश्चन पढ़ के ये सोचो कि अगर मैं एग्जाम में बैठा होता तो मैं कैसे अप्रोच करता. फिर वो वैसे ही हुआ है क्या? This will give you confidence if you're doing it correctly. And suppose if your thought process was incorrect, that will get rectified and you won't do that mistake 3 days later in the examination. So let's see the first question. This is the first question we have. Find the value of the voltage Vx. Quickly think how will you handle this question. Find the value of voltage Vx. Now see, he is asking us to calculate the value of the voltage Vx. x. How are you going to handle this question? The easiest way that I can think about in this question is to go with the nodal analysis, as I told you also that we are going to apply the nodal analysis. Now if you see, let's apply the nodal, okay? Let's redraw it over here so that we can mark the node voltages. Now see, let's say, because first you will have to find the principal nodes, and we can easily notice 1, 2, 3, 4, 5 principal nodes are there. Out of these 5 nodes, one node I want to pick as the reference node. So I am thinking that let's pick this one as the reference node. So I don't want to pick this one, I want to pick some other one. It's okay, you can go with that. This one will be a good option, so that this will become model 2. Model 2 was, what was model 2? When a voltage source is connected between a non-reference and a reference node. Okay, so if you can see, I have picked it, I have made this one as model 2 so that one node equation gets reduced. Mark them. Let's say this is node V1. Okay, this is V2, this one V3, V4. Moreover, I won't be solving the equations, will be making the equations, but I won't be solving the equations, okay, because that will be the wastage of time. I'll straightforward, I'll have already solved all the questions, I'll be just giving you the answers for your cross check, so that when you solve at home later on, you can cross check your answers. Now, if you see over here, V4 is directly coming equal to 200 volts. Because, why I am saying so? Because this voltage source is connected between a non-reference and a reference node. So obviously its voltage directly we can write equal to 200, higher potential minus lower potential. V4 minus 0 will be equal to 200, so V4 is equal to 200 volts. Now let's develop the equation over here. Now when you develop the equation over here, you people get confused actually. Why, sir, why we can confuse? Because you write for this one, then you get confused, what about this one? 2 voltage sources back to back. So this time the super node will be formed by node 1, node 2 and node 3. 3 nodes will be making the super node instead of 2 nodes. So the concepts remain the same. You just have to expand the things that you have learnt. So let's develop the equation. The first way is that mark the currents that are basic method I told you, plus plus I1 in this case. For this node it will be minus I1, this current will be plus I2, for this one minus I2. When we add these, plus I1 minus I1 cancel, plus I2 minus I2 cancel, finally we get an equation. We are not going to do that because that is for the learning the concept. Now we will be directly writing the equation what I told you. हम जितने भी nodes हैं super node के बीच में, हर node पे KCL equation लिखेंगे, हर और उन nodes के साथ जितनी branches connected हैं उन सब के लिए KCL equation लिखी जाएगी, सिर्फ उन branches को छोड़ दिया जाएगा जो super nodes के बीच में connected हैं. For example, if you see over here, okay, let me start writing the equation, then I'll show you. First, for node, starting at super node this one, 1 to 3, I'm starting at node 1. This will be outgoing current, so plus 4 plus outgoing current V1 minus 0 divided by 40, so V1 by 40. Then this I won't be writing between super nodes. If you see carefully, 10 ohm is also connected between 2 super nodes because 1, 2 and 3 are forming the super nodes. So 10 ohm is connected between 1 and 3, so I won't be writing for this one also. Okay, so that's all for node 1. Let's move to node 2. For this branch I will not write. For this incoming, so minus 6 plus outgoing V2 by 50. So I have taken care of this one, these two we won't be writing. Let's move to node 3 plus at node 3, not for this branch. Can I write it for this one? No, I cannot. Why? Because this branch is connected between 2 nodes which are forming the super node, so I won't be writing for this one. What about 8? Yes, outgoing, so 8 plus, what about this branch? Of course V3 minus V4 divided by 20 plus V3 minus V4 divided by 20. Have a look over here again. हमने उन सब ब्रांचेस को कंसिडरेशन में लिया है जो सुपर नोड्स के बीच में कनेक्टेड नहीं है. जैसे यहाँ पे हम चेक करेंगे, सो आप देख सकते हैं इसके लिए नहीं लिखेंगे, इसके लिए नहीं लिखेंगे, इसके लिए लिखेंगे +4, इसके लिए लिखेंगे V1/40। फिर नोड 2 पे आए, इसके लिए नहीं, इसके लिए नहीं, इसके लिए V1/50 एंड देन -6 इनकमिंग, V2/50 -6 इनकमिंग। देन कमिंग टू नोड 3, ये इन दोनों के लिए नहीं लिखेंगे, ये लिखेंगे बाहर जा रही है +8। फिर इस ब्रांच पे लिखेंगे हायर पोटेंशियल V3 माइनस लोअर पोटेंशियल V4 डिवाइड बाई 20 इज इक्वल टू 0। ठीक है, तो ये हमारे पास सुपर नोड पे इक्वेशन बन के आ गई। तो मैं आपको यही दिखाना चाहता था, बिकॉज कंफ्यूजन इसमें ये आता है कि जब ये बैक टू बैक कनेक्टेड हैं, 3 नोड मिलकर सुपर नोड बना रहे हैं, उसको कैसे हैंडल किया जाए। So I think we have learned that concept from here. Now next thing will be to substitute V4, because calculation I won't be doing, you have to do it on your own over here. Okay, substitute the value of V4, solve this equation, you'll be getting your first equation. Second equation कहाँ से मिलेगी? Second मिलेगी super nodes के about KVL लगा के. So you can see higher minus lower, that is V1 minus V2 will be equal to the battery value or the EMF 400 volt. Equation number second. Next equation, फिर super node पे KVL, so V2 minus V3 will be equal to 4Vx. V2 minus V3 will be equal to 4Vx. And what is Vx equal to? Vx, as you can see from here, as Vx is equal to higher minus lower, that is V3 minus V4. Vx क्या हो जाएगा? Higher potential V3 है, minus lower क्या है? V4. So V3 minus V4. You substitute it over here in this equation, so you'll be getting V2 minus V3 will be equal to 4 times Vx, that is 4V3 minus 4V4, equation number 3. You have 3 unknown variables because V4 value is already known to us. So you substitute V4 over here. So I have 3 unknown variables and 3 equations. If I solve these 3 equations, I'll get the value of V1, V2 and V3. So let me write the final values for you, the answer V1, V2 and V3, because we won't be wasting time in solving this. V1 is coming as 145.45. V2 you will get as minus 254.54 volt. This is just for you, so that when you solve to check your calculation, 109.09 volts. And Vx finally is V3 minus V4, you substitute the value of V3 and V4 is 200, so it will be minus 90.91 volts. This is the answer that you will be getting. Okay. So this was a nodal question. The important concept is when they are connected like this, okay, back to back, how will you handle this kind of question. And nodal is important, you know that it gets utilized a lot of times. So let's move on, let's see the next question. This is the next question that we have. We won't be solving this question. I just want to tell you one concept. See, when you have, suppose he has asked you to calculate V1, V2 and V3. How will you do that? Obviously you're going to apply the nodal analysis. When you apply the nodal, sometimes you do the mistake for S. When Siemens is there, you do the mistake. So it can be either Siemens or Moho, वो कुछ भी दे सकता है आपको. तो इस समय इक्वेशन लिखते टाइम गलती नहीं करनी है, ठीक है. तो आप इस क्वेश्चन को प्रैक्टिस करिए. मैं एक के लिए इक्वेशन लिख देता हूँ, बाकी के लिए आप खुद प्रैक्टिस कीजिए. It is just to show you the kind of the model, because nodal question कर लिया है, it will be wasted of time if I solve one more question, but the concept is important. So see, incoming will be minus 2 plus outgoing will be V1 multiplied by 2, because V by R is the current or V into G is the current, and I need the current value, that will be V into G, that is V1 into 2, plus for this branch it will be V1 minus V2 outgoing multiplied by 1, then for this branch plus 3 I0, then for this branch, so plus V1 minus V3 multiplied by 4 is equal to 0. So when Siemens is given or Moho is given, please pay a little bit of attention while writing the equations that do not divide it by that value, multiply it instead of dividing. So what we did, incoming minus 2, outgoing V1 into 2, outgoing V1 minus V2 into 1, plus outgoing 3 in I0, plus outgoing V1 minus V3 into 4, where I0 value is V2 into 4. Then substitute, make equations and get the answer. Let's see whether I have the answer for this one or not. Final answer, no, I do not have the final answer for this question, so you solve it on your own to get the final value for this question, but remember the concept that I want you to learn from this question. So Nodal we saw. One more method is important, that is mesh analysis. See, we do not apply the mesh analysis very often. When we are sitting in the examination, you know, always we have this kind of a feeling to go with the nodal actually to get our answer, but sometimes you will notice that mesh becomes a better option to go with. So we need to know mesh also. I'll take one question because that is important. Nodal and mesh are really very important methods actually from the examination perspective. So let's see one more question from the mesh perspective. This is the next question that we have. So now you see, this is the question that we have. Find the currents Ix, Iy and Iz. What are the currents? These are the currents Ix, Iy, Iz. These currents he wants you to calculate. You want to go with the nodal? Be my guest. Try it. Practice is more important. But I'll solve this with the help of the mesh analysis. Let's see. Let's use this circuit only. So now, if I am solving it with the mesh, so I have to assign the mesh currents. So let's say this is mesh 1, the current is I1, this is mesh 2, the current is I2, mesh 3, the current is I3, mesh 4, the current is I4. So this is what we have. Now let's solve this question by developing the mesh equations. So if you notice, do we have model 2 and model 3 of mesh? Again, I have tried to pick that question in which we can have all the models. One question complete. If you notice, this current source is connected in a separate mesh. When a current source is connected in a separate mesh, we can directly write the current of that mesh. There is no need to develop the equation, so one equation gets reduced. One more thing, if you see, this current source is connected in between two meshes. When a current source is connected in between two meshes, we go for the super mesh analysis. So what is the super mesh that we have over here? So let's see, this is the super mesh that I am talking about. Can you see now? Because this current source is present in between these two meshes, so if I remove this or combine these two meshes, the bigger mesh that I'll be getting will be super mesh. The name suggests super, the bigger mesh that we're going to get over here. So let's solve this. Let's make the equations. So if I go for first one, you can straightforward see the current I1 is coming equal to 4 ampere, model 2 of mesh. Okay, I1 is like this, 4 is also like this. Okay, so I1 is coming equal to 4 ampere. Next, let's develop in the super mesh. I am applying the KVL in super mesh. So if we apply the KVL in the super mesh, let's start from here. I'll be coming like this, so it will be plus 10, reaching over here, plus 2 times only I3, so I3, moving from here, plus 4 times 2 currents. I'm moving in this mesh, so I'll be writing I3 minus I4, I3 minus I4, reaching over here, plus 6 times again this mesh, so I2 minus I1, and this is equal to 0. Let's have a look what we did. We started from here, this is a super mesh, so I'm applying the KVL in the super mesh. I started from here, plus 10, reached over here, 2 times I3, so I got 2 times I3. Then I reached over here, it will be 4 times I3 minus I4, because from this resistor two currents are flowing. I am moving in mesh 3, so I assumed its current to be the largest current for writing the KVL equation. When I reached over here, again I2 minus I1 into 6. So I2 minus I1 into 6 and loop is over. From super mesh we make two equations, one by applying the KVL and the by applying the KCL. So if I apply the KCL over here to get the second equation, so either you can apply the KCL at this node or you can directly see I2 minus I3 will be equal to 1. Equation number second, equation number third. Okay? Because you see, one is in the downward direction and one is the resultant of current I2 and I3. So if it is in downward direction, it means I2 must be greater than I3 and the difference should be equal to 1. तो वही हमने यहाँ पे लिखा है, या फिर आप इस पॉइंट पे KCL लगा लोगे तो भी आपको यहाँ से I2 minus I3 equal to 1 मिल जाएगा. तीन इक्वेशन आ चुकी हैं. One more, means this is not the equation, this is the value that I have. Now one more equation that I need, that I'll get from the mesh 4. So let me write it over here. So I'm applying the KVL in mesh 4. So if I apply the KVL over here, let's start from here. It will be minus 8 plus 12. In between two meshes, what are the currents? I4 minus I1. I4 minus I1 plus reaching over here 4 times difference of these two currents I4 minus I3 is equal to 0. ठीक है, यहाँ से मूव किया -8 आया, इस रेजिस्टर से दो करंट फ्लो कर रही है, सो I4 minus I1, यहाँ से भी दो करंट फ्लो कर रही है, I4 minus I3. This is equation number 4. Now you have three equations, 2, 3 and 4, and in these three equations we have three variables. By solving these three equations we can get the value of I1, I2 and I3 and I4, and from there, because I1 we have already calculated, तो अब यहाँ से I2, I3 और I4 निकाल लेंगे और वहाँ से IX, IY और IZ निकाल लेंगे. मैं आपको वैल्यूज लिख देता हूँ, फाइनल आंसर क्या आएगा. So the final answer that we'll be getting will be I2 will be equal to 3 ampere, I3 this will be coming equal to 2 ampere, I4 this is equal to 4 ampere. तो वहां से हम IX, IY और IZ निकाल लेंगे. अगर आपको वो भी चाहिए तो मैं लिख देता हूं. IX हमारे पास आ रहा है -1, IY this is coming as 0, IZ this is coming equal to 2. You can check over here. IX is I2 minus I1. IX is I2 minus I1. I2 is 3 and I1 is 4. 3 minus 4 minus 1. What will be I1? Sorry, IY. IY will be equal to I1 minus I4. So I1 2 minus I4. IY we are calculating. So IY is coming as I4. I1 minus I4. So I1 is 4 minus I4 4. This is coming as 0. And IZ will be I4 minus I3. So I4 minus I3 will be 2 amperes. So calculation that you can do on your own. The thing is that we just want to see solve the questions. We just want to learn the concepts there that are important from the examination perspective. So it's a good question because we saw in this the super mesh, model 2 and normal calculation also. So let's move forward. Let's see the next question. So now this is the next question that we have. In this question, we have to find the value of the current I2. Seems like a lengthy question. Take 10 seconds, quickly take 10 seconds to think how will you solve this question. Take 10 seconds. Okay, few, in chat you are writing few things. Firstly, good evening to everybody, those who have joined late. Good evening, and I'm fine. Some of you have asked how are you. I'm absolutely fine, and I hope you're also doing good at your home and safe and sound from the corona and prepared for the examination. Apart from that, one student has asked that, sir, is GATE examination tougher than ESC examination? Forget about all those things. Once you are prepared for the examination, once you have learned the subject, it doesn't matter what kind of an examination you are preparing for, be it GATE or ESC, you're going to crack that. Because normally you have this kind of feeling, sir, in ESC the objectives are easy and in GATE are tough. So you have the mains examination also, so it's not like that. Do not get frustrated or do not think about all these things before the examination. Just go for the exam. आई होप आपने ये सॉल्व कर लिया होगा. इसमें करंट I2 उसने पूछा हुआ है निकालने के लिए. जो लोग ये सोच रहे हैं सर इतनी जल्दी सॉल्व हो ही नहीं सकता, अभी तो सोचना ही शुरू किया था. तो देखो बच्चे, बहुत आसान क्वेश्चन है. इफ यू गो विद द सुपरपोजिशन थ्योरम, इट्स रियली वेरी इजी. So how will I think about superposition theorem in this question? If you have identified that this is a bridge, because क्लास में बहुत मैंने ब्रिजेस आपको दिखाए भी थे, ब्रिज ऐसे काफी हिडन वेज में ब्रिज देखे थे हम लोगों ने. So if you have identified that it is a bridge, the question is over. How? See, first, when I go with the, I'll show you in detail also. First, just have a overview. because एग्जाम में बैठे होते तो जल्दी से कैसे हो जाता है ये. अगर मैं 2 वोल्ट की वजह से यहाँ पे करंट निकालूंगा, शॉर्ट ओपन, तो आप देख रहे हो ये प्रॉपर ब्रिज बन जाएगा. ये तो शॉर्ट हो जाएगा, ये बाहर वाली आर्म हो गई उसकी. ब्रिज बैलेंस्ड है, हाँ ब्रिज तो बैलेंस्ड है. सेंट्रल आर्म में करंट 0, तो 2 वोल्ट की वजह से यहाँ करंट कितनी आई? 0. जब मैंने 1 एम्पेयर लगाया, शॉर्ट शॉर्ट, दोबारा से ब्रिज, सेंट्रल आर्म 0, ना ये करंट दे पाया ना ये करंट दे पाया. अब आते हैं इसके ऊपर 2 वोल्ट पे. तो अब अगर आप देखो तो 2 वोल्ट को बाहर ले लेते हैं, क्योंकि अब ये भी शॉर्ट और ये भी शॉर्ट है, और इस 1 ओम का सेंट्रल आर्म मान लेते हैं. अब आपको पता है, ये क्लास में मैंने बताया भी था, यू मस्ट हैव रेड दैट आल्सो इफ यू हैव स्टडीड एट योर ओन, कि अगर ब्रिज की सारी आर्म्स की रेजिस्टेंसेस बराबर हैं, in that case the equivalent resistance will be equal to that resistance only. That is, if I have a bridge और ब्रिज की जो आर्म्स हैं वो R R R R हैं, सेंट्रल आर्म से मैटर नहीं करेगा, R R R R हैं, तो इसकी इक्विवेलेंट रेजिस्टेंस भी R ही होगी. बात समझ में आई? तो अब अगर आप नोटिस करो, ये शॉर्ट हो गया है ना, मतलब सॉरी ये शॉर्ट और ये ओपन हो गया है, तो ये बचा मेरा सोर्स वाली आर्म. बचे हुए ब्रिज की इक्विवेलेंट रेजिस्टेंस कितनी होगी? 1, बिकॉज इन सब आर्म्स की रेजिस्टेंस इक्वल है, R है 1 1 1, तो इक्विवेलेंट रेजिस्टेंस भी 1 हो जाएगी. इसका मतलब इस ब्रांच को जो इक्विवेलेंट रेजिस्टेंस नजर आएगी वो 1 नजर आएगी. अगर वो उसको 1 नजर आएगी तो आप देख सकते हो I2 कितना आ जाएगा? I2 will be equal to opposite direction, so -2 divided by equivalent resistance कितनी बची सर्किट में? 2 plus 1, that is 3, -2/3 एम्पेयर will be our answer. अभी तो समझा रहा था और टाइम लगा, अदरवाइज आप क्विकली देखते. अच्छा, ये ब्रिज बैलेंस्ड है, शॉर्ट, इन दोनों की वजह से 0, बस इसकी वजह से कैलकुलेट करना है. ये हटा, इक्विवेलेंट रेजिस्टेंस 1 आई, 2/3 ऑपोजिट डायरेक्शन में, -2/3 एम्पेयर इज आवर आंसर. तो सुपरपोजिशन थ्योरम कई बार बहुत इफेक्टिव हो जाती है क्वेश्चन सॉल्व करने के लिए. तो उसको ऐसा नहीं सोचना है कि सर वो तो हम कभी लगाएंगे ही नहीं, 3 बार सॉल्व करने से अच्छा नोडल लगा दें. बिल्कुल सही बात है, बट समटाइम्स दीज काइंड ऑफ क्वेश्चंस अपीयर इन द एग्जामिनेशन, सो कीप योर माइंड ओपन एंड ऑलवेज ट्राई टू थिंक फॉर द ब्रिज. कहीं ब्रिज तो नहीं दी और बैलेंस तो नहीं है, ऑलवेज कीप योर आईज ओपन फॉर दैट. चलिए देखते हैं इसको. सर कोई और तरीका सॉल्व करने का? हाँ, एक और तरीका हो सकता है इसको सॉल्व करने का, बाय गोइंग विद द मैश एनालिसिस. यहां मत लगाना मैश, क्या कर सकते हो? सोर्स ट्रांसफॉर्मेशन. इसको सोर्स ट्रांसफॉर्म करोगे, a current source connected in parallel with the resistance, 2 current sources in parallel can be replaced by a single current source. तो एक सिंगल करंट सोर्स, एक रेजिस्टर, वापिस सोर्स ट्रांसफॉर्मेशन. तो यहाँ पे करंट सोर्स नहीं बचेगा, एक वोल्टेज सोर्स, एक रेजिस्टर बचेगा. 1 2 3, 3 meshes, solve that, get your answer. But I hope you can understand that will be a little bit lengthy. तो मैं आपको एडवाइस नहीं करूंगा. सुपरपोजिशन अगर स्ट्राइक कर गई तो आप यहाँ पे टाइम सेव कर लेंगे एग्जाम में. तो ब्रिज का ध्यान रखना, कहीं इस तरह का क्वेश्चन आए तो हैंडल कर लेना. दिस इज अ वैन वेलकमबर्ग क्वेश्चन, एक्चुअली आई टुक इट फ्रॉम देयर, इट वाज अ गुड क्वेश्चन एक्चुअली. नाउ अब प्रॉपर्ली सर आपने क्या बोला, कुछ बच्चे जो फॉलो नहीं कर पाए, सर वो जल्दी समझ में नहीं आया, तो चलिए आराम से चलते हैं, स्टेप बाय स्टेप देखते हैं. आई एम सेइंग दैट लेट्स गो फॉर द सुपरपोजिशन थ्योरम. इफ आई एम गोइंग फॉर द सुपरपोजिशन थ्योरम, सो लेट्स फर्स्ट एक्टिवेट वन सोर्स एट अ टाइम. सो सपोज आई हैव एक्टिवेटेड 2 वोल्ट सोर्स. सो व्हाट circuit I'll be getting? This is the circuit that I'll be getting, isn't it? This source I have kept, deactivated, so replaced by an open circuit, deactivated, replaced by a short circuit. Now in this question I have to calculate the value of I2 dash. Now can you see this is a bridge? देख रहे हो बच्चा, वो ऐसे और ऐसे बनाते हैं, अब ऐसे और ऐसे बना दिया हुआ है और कुछ नहीं है. इसको ऐसे जोड़ दो ऐसे करके और इसको ऐसे जोड़ दो, ये ब्रिज नजर आएगा आपको. So this is the bridge that I have and this is the central arm. and as the bridge is balanced, the current through the central arm will be 0. So I can write over here I2 dash is equal to 0 ampere. Now in the second case, let's activate the 1 ampere current source and let's deactivate the voltage sources. So now 1 ampere current source we have activated, deactivated these two voltage sources. Again it's a bridge. No sir, I have always seen the bridge with a voltage source and a current source. I am getting a little bit confused. It's not at all problem. Only concentrate on this portion. Can I draw it like this? वन ओम 1 एम्पियर और आगे बचा हुआ सर्किट. ठीक है बच्चे, मैंने इतना सा बनाया है. ये यहाँ की बजाय यहाँ ले आया इसको और इसको यहाँ की बजाय यहाँ ऐसे लिख दिया मैंने. ठीक है, और ये 1 ऐसे की बजाय मैंने यहाँ बना दिया. एक ही बात है. नाउ we can go for source transformation, and when I go for source transformation, it will be changed into a voltage source connected in series with a resistor. फिर बचा हुआ नेटवर्क आगे 1 into 1 1 volt, resistor will be 1 ohms. तो अब देखो, अब ये यहाँ लगा होता अगर, अब तो वो सेम वैसे ही बन गया ना ऐसे वाला voltage source and resistor. So I hope now you can understand it's a bridge. Again it's a balanced bridge. Current I2 double dash will be 0. So let me write it over here. I2 double dash, this will also be 0 ampere. Now the last case, let's activate the 2 volt source. So when I activate this 2 volt source, okay, open, short, this is the circuit that I am left with. Now what? If you can observe, very good, सेंट्रल आर्म के जो सेंट्रल आर्म दोनों ही होती है, बट जो बीच में आएगी वो इसको बीच में बना लो और इसको बाहर से बना दो, सर्किट तो वही बनेगा. बट आई एम रीड्रॉइंग द सर्किट कि आपको थोड़ा बहुत डाउट ना रह जाए. लेट्स रीड्रॉ इट, बट नेक्स्ट टाइम ऑनवर्ड ट्राई टू अंडरस्टैंड दिस कॉन्सेप्ट दैट आई टोल्ड यू, बिकॉज ये पहले बाहर वाली थी अंदर वाली थी, तो क्या हो गया, इसको बाहर बना दो उसको अंदर बना दो, बात तो वही रहेगी. सेंट्रल आर्म तो ये है, बैलेंस्ड हो जाएगा ब्रिज. चलो यहाँ देखते हैं. आई एम रीड्रॉइंग द ब्रिज, दैट्स व्हाई आई हैव मार्क्ड द पॉइंट्स A, C, B एंड D. इसके साथ में इसको यहीं बना देते हैं. इट विल बी इजी फॉर यू टू ऑब्जर्व. चलिए यहाँ देखते हैं. A और C के बीच में 1 ओम कनेक्टेड था, A और C के बीच में 1 ओम कनेक्टेड है. C और B के बीच में 1 ओम कनेक्टेड था, C और B के बीच में 1 ओम कनेक्टेड है. A और D के बीच में 1 ओम था, A और D के बीच में 1 ओम है. D और B के बीच में 1 ओम था, D और B के बीच में 1 ओम है. बस ये जो मैंने बाहर से बनाया था A और B के बीच में, वो मैं अंदर से बना रहा हूँ A और B के बीच में. ये A और B, ये B पॉइंट आ गया, A आ गया. ये जो अंदर बनाया था हमने C और D के बीच में, ये मैं बाहर से बना रहा हूँ C और D के बीच में. यही मैं आपको बोलना चाह रहा था कि अगर ब्रिज है तो वो अंदर बाहर का कोई फर्क नहीं पड़ता है. जस्ट इमेजिन कि ये एक्साइटेशन वाली ब्रांच है और ये सेंट्रल ब्रांच है. ओके, तो अब आपको सामने सामने दिख रहा है. अगर यहीं पे देखते तो ये हमारा क्या होता, डमी, बिकॉज करंट तो फ्लो करती नहीं यहाँ से. सो वी कुड हैव रिप्लेस्ड इट ईदर बाय शॉर्ट सर्किट और बाय एन ओपन सर्किट, बोथ वी कैन डू. सो लेट्स रिप्लेस इट बाय एन ओपन सर्किट, बिकॉज रजिस्टर्स है तो ओपन सर्किट प्रेफरेबल है. तो हमने इसको ओपन सर्किट से रिप्लेस कर दिया. अब इसकी इक्विवेलेंट रेजिस्टेंस निकालेंगे, वो 1 ओम आएगी. तो मैं आपको ऑलरेडी बता चुका हूं कि अगर ब्रिज की ये जो आर्म्स है, सेंट्रल आर्म का फर्क नहीं पड़ेगा, अगर ये जो आर्म्स है इनकी रेजिस्टेंस बराबर है तो इक्विवेलेंट रेजिस्टेंस जो होती है वो उसी के बराबर आती है. तो ये पूरा किसके बराबर आ जाएगा, 1 के बराबर. एंड दिस होल विल बी 1. सो आई होप नाउ यू कैन सी I2 ट्रिपल डैश, बिकॉज ये ऑपोजिट डायरेक्शन में है. जो इस साइड करंट आती है वो कितनी आती, वोल्टेज अपॉन रेजिस्टेंस विल बी 1 plus 2, that is 3, but this is opposite to this current, so minus. And now if we apply the superposition theorem to get the complete answer, so I2 will be I2 dash plus I2 double dash plus I2 triple dash. 0 plus 0 minus 2 by 3, so the answer will be minus 2 by 3 ampere. I hope you got the concept what I wanted to tell you. Superposition theorem को बिल्कुल नेग्लेक्ट नहीं करना है, सोचना है. बाकी कुछ मॉडल्स होते हैं स्पेसिफिक दैट वी हैव डिस्कस्ड इन द क्लास वेयर यू डू नॉट हैव एनी अदर ऑप्शन इंस्टेड ऑफ गोइंग फॉर सुपरपोजिशन थ्योरम. एंड ब्रिज आइडेंटिफाई करना ज़रूरी है, बिकॉज कई बार होता है वो ब्रिज को छुपा के देते हैं सर्किट में. अगर आपने ब्रिज आइडेंटिफाई कर लिया तो क्वेश्चन सॉल्व कर लिया. ठीक है, लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन. तो ये हमारे पास नेक्स्ट क्वेश्चन है. 30 सेकेंड्स लीजिए, क्विकली सॉल्व करने की कोशिश कीजिए. Jessica Green, sir, in English please. Okay, I'm trying my level best to teach everything in English. Few students have written superposition theorem. Sir, transient के question बच्चा बिल्कुल आएंगे. आकाश, transients के question, because that's a good topic, important topic. We will see few questions. And Rohan, a nice question, sir. Thank you so much. And thank you. Okay, now moving on to the next question. Try आपने I hope किया होगा, सोचा होगा. In this question you have to find VTH and RTH. He wants you to calculate the Thevenin model indirectly. Thevenin model वो हमसे बनवाना चाह रहा है. तो ठीक है, Thevenin model solve करते हैं, देखते हैं कैसे solve होगा. So the first step will be to calculate VTH, or you can go with RTH also. This is not a fixed rule that which one you want to solve first. So let's go with VTH. So for calculating VTH, obviously A and B terminals are marked, so I have just write VTH over here. Now, what method you think of? See, it's all about thinking the method quickly at that time. At that time when you are sitting in the examination, and go with that. Okay. So what I am thinking actually, I'm thinking that if I calculate the current, then I can easily go for the current division to get my answer. So why you are saying so? I'm saying so because open, no current in these two branches. So in series, 2 and 4 in series 6, 6 and 6 in parallel 3, I can easily calculate the current 4. Then when current will reach over here, that will get equally divided between these two branches, and then I can apply the KVL to get my answer. This is the easiest way I can think of right now in this question. So let's go with this. I'm sorry. Now 2 and 4 in series 6, 6 and 6 in parallel 3. So what will be the current value now? 24 divided by 6, that is 4 ampere. वो 4 बच्चे यहाँ पहुँचेगी और फिर इन दोनों में 2 and 2 होके डिवाइड हो जाएगी. देखते हैं एक बार. Let's see it in the circuit form. Have a look. यहाँ से 4 आई, यहाँ क्योंकि यहाँ तो ओपन है, करंट जाएगी नहीं. So whatever current is coming from the source, the whole current will flow through this resistor. After reaching this resistor, this current will be having two paths, this one and the parallel path, because again this is open, no current will be flowing in this branch. As these two paths have equal resistance, therefore the current will get equally divided between these two, 2 and 2. Now you want VTH, apply the KVL in this loop. If I apply the KVL, you can see VTH will be equal to 3 into 4, 12, plus 2 into 2, 4, and this is coming as 16 volts. ठीक है, हमने यहाँ पे बच्चा KVL लगा दिया. If I apply the KVL, VTH will be 3 into 4, 12, 2 into 2, 4, 12 plus 4, 16 will be our answer for VTH. Want to calculate RTH? For calculating RTH, we will be deactivating all the independent sources and doing the calculation. So let's go for RTH. So what I have done, I have deactivated the voltage source. Now after deactivation, you know that whenever we have to calculate the equivalent resistance and we are unable to find straightforward, what we do, we mark the points, because this is the basic rule that we start the equivalent resistance topic with. So what I have done, if this is point A, point A, point A, point A, and this is point B. This is a new point, so I have marked it as C. I want the equivalent resistance between the points A and B. So I told you, first draw those 2 points. That is, between A and B, I have to mark. Okay, first I have to mark A and B, because between those 2 terminals we want to find RTH. If you see A and C, 6 ohm is between A and C, 3 ohm is between A and C. These two will be in parallel, and then between A and B I'll be having 4 ohm, and then between B and C I'll be having 2 ohms. Let me draw the circuit over here, it will be easy. Have a look over here. A and B, between A and B, we have 4 ohm. So we always mark that points first, those points first, in which we are between which we are trying to find the equivalent resistance. So A and B, 4 ohm we marked. Then between A and C, 3 ohm is connected. So I just mark this one. Between A and C, 3 ohm. Between A and C, 6 ohm. Again, between A and C, 6 ohm. Between B and C, 2 ohm. So C point we already have, B we have 2 ohm. This is a circuit that I'll be having. Now, 3 and 6 connected in parallel. You know that 3, 6 will be 2. 2 and 2 in series will be 4. So can I write RTH will be 4 parallel with 4, that is 2. Means, let me write it properly. 4 parallel with the series combination of 2 and 2. So 4 parallel with 4, this is coming as 2 ohm. So we have calculated VTH and RTH. So remember the equivalent resistance concept. You already know these things, studied in the class in great detail. And this is a different thing because point B was going to get eliminated for calculating I and then current division back. So if you want to go with other method also, you can, but I think the current division method is the easiest one in this question, and it's a good concept. So it's not you need not to have to go for always nodal and mesh, because whenever you see a question, you do not think about KCL or KVL or current division or some other method. You straightforward go with the nodal. That's what you do most of the time. Please do not do that. You can think about something else also, like in this question. So let's move forward. Let's see the next question. So this is the next question. You have to find VTH and RTH between the terminals X and Y. Take 30 seconds to calculate RTH. Okay, VTH I'll calculate later on. First you go with RTH because I want to show something in this question. Take 30 seconds quickly but solve this question. Only 30 seconds I'll be giving. Try to solve it. Okay, Mangesh is coming as 2 ohm, 2 ohm, everybody is saying the 2 ohm, okay. Let's see how you have solved this question. Okay, let's solve this question, let's see how to solve this question. If you want to calculate VTH and RTH in this question, let's do one thing. Let's go for VTH first, okay. So let me see, can we copy this? Let's copy this one, paste. Now I want to calculate VTH, so between the terminals X and Y, plus minus VTH, this is what we want to calculate. So let's say the current flowing in the circuit is some current I, okay. So if I apply the KVL in this loop, okay, in this loop if I apply the KVL, because VTH is what I want to calculate, so you can see VTH will be equal to minus 1 plus 2V, okay. This is what we have, minus 1 plus 2V is the equation over here. So you will get the value of VTH if you can calculate the value of V. For calculating the value of V, let's concentrate over here. So I'm applying the KVL in the whole loop now. So this, if I apply the KVL in the whole loop, we'll be having minus 2V plus 1 plus I into 1 I minus V is equal to 0. What I am interested in is in calculating V. So let's eliminate I from here. What will be I value? I will be voltage upon current, so can I write minus V divided by 1? I hope you can understand the minus sign. Because अगर इस voltage को देखें तो current कैसी होनी चाहिए? यहाँ से ऊपर क्या होगी current? V by 1, opposite है, so minus V by 1 or whatever way. Polarity reverse कर दो, so it will be plus, this will be minus, it will be minus V, so minus V by 1. Therefore, what I am getting is minus 2V plus 1 minus V is equal to 0. So from here you can see V is coming equal to minus 4 V. So 1 by 4 volts is the V value. Let's substitute it over here in first equation. So if I put it in the first equation, VTH is coming equal to minus 1 plus 2 into 1 by 4, that is 1 by 2. Therefore, Thevenin is coming as minus 1 by 2 volts. This is VTH. Let's see, anybody answered this question correctly? Very good. First, M. Sridhar, minus 0.5. Rohan, minus 0.5. I don't know whether you have written voltage or resistance, but yes, good. Madhu, good. Good. Few questions I have answered it correctly. I am very happy. Swatantra Kumar also have written minus 1 by 2. Excellent. So, minus 1 by 2 volt is the correct answer for the Thevenin voltage. Now, let's go for the Thevenin resistance. That's the important point I want you to see over here. Okay, so let me paste the circuit over here. See very carefully this part, okay? Now, you want to calculate RTH, what you're going to do? You're going to deactivate all the independent sources. So this is going to get replaced by a short circuit. So I will So I have replaced it by a short circuit. और यहाँ से बच्चा equivalent resistance निकालेंगे and that resistance will be RTH. Okay. Now, if I have a dependent source in the circuit, what I'm going to do? I'm going to connect an excitation over here. So, excitation provide करवाते हैं यहाँ पे. Let's connect a voltage source or a current source, whatever you want to connect over here, but I have to connect a current source because you know that the concept actually we have dealt in great detail. If I connect a voltage source, then I'll be defining the value of the dependent source, which we shouldn't be doing because this variable should be defining its value. So we never connect an independent voltage source in parallel with the dependent voltage source. So 1 ampere I'm going to connect over here. Now, you want the Thevenin resistance? It means you need to find the voltage across this one. Let's say the voltage is Vx, let's say. So Vx by 1 will be RTH. Now my task is to calculate the value of Vx. Fine. First equation that you can straightforward see from here, Vx is coming equal to 2V. Equation number, I don't know how many equations we have written, only one we have taken. Okay. Equation number 2. Vx 2V के बराबर आ गया, सीधा सीधा एक चीज आ गई. अब दोबारा निकालते हैं, तो अब यहाँ से Vx निकालेंगे. Vx कितना आएगा? If you see, minus Vx, I'm applying the KVL, okay? Minus Vx. बच्चा अगर यहाँ पे minus V drop आ रहा है, तो यहाँ पे भी minus V आएगा. Same resistor, equal drop. So, this will be equal to minus V equal to 0. Or can you see Vx is coming equal to minus 2V? Equation number 3. Can we equate equation number 2 and equation number 3? Let's do it. So I'm equating equation number 2 and equation number 3 because on the left hand side in both the equations I have Vx. So Vx will be equal to 2V will be equal to minus 2V. This is the equation that I am getting. Isn't it a little bit absurd? How can Vx is equal to 2V and Vx is equal to minus 2V at the same time? Is there any possibility in which this can happen? Any possibility that you can think of, that you can comprehend, actually you can come up with? I think I can come up with one possibility. This equation can only hold if V is equal to 0. If V will become equal to 0, both the equations, second and third, will hold and I'll get my answer. Okay? Therefore, Vx is coming equal to 0 volts. Therefore, from here you can see RTH will be equal to Vx upon 1, which is coming equal to 0 ohms. This is my answer. I hope समझ में आया होगा. ठीक है, तो ये देखो अभी जैसे मैंने जब क्वेश्चन लिखा होगा आपको लगेगा अरे इतना आसान क्वेश्चन है सर, ये तो हम कर लेंगे, आप क्या करवा रहे हैं. But when you go to the examination, you do these silly mistakes, these small mistakes in the examination. So it was a good question. Just take 5 seconds just to comprehend what we did over here, how we calculate the RTH, and then we will move on to the next question. I hope बच्चा आपने कर लिया होगा. Let's move on to the next question. There is one more question about related to this that I'm thinking of, but उसके लिए मुझे question frame करना पड़ेगा because मैं solve कर रहा था तो I just याद आया question और बन सकता था. देखते हैं, टाइम मिलेगा तो वो भी देखेंगे. पहले आगे चलते हैं, थोड़ा सा मूव ऑन करते हैं. सी आई एम नॉट टचिंग द नॉर्टन थ्योरम बिकॉज नॉर्टन एंड थेवेनिन आपको पता है ब्रदर एंड सिस्टर टाइप के हैं, दोनों सेम है. सो इट विल बी वेस्टेज ऑफ टाइम एंड मोस्ट इंपॉर्टेंट इज द Thevenin theorem. Maximum power transfer theorem, if you talk about this, very important from the examination point of view. So if a normal question appears, then you just have to apply the Thevenin first. So you can do that. Otherwise, the special cases, when we have a load which is complex, you have to simplify it. Those questions we have done a lot of times, and if you have solved the PVC gate questions, you must have encountered that also. So I'm not dealing with those kind of questions over here because in every, no matter where you have studied, those questions have been taken care of. And the conditions in AC, power transfer in case of AC circuits, remember that if both RL and XL are variable, then ZL should be ZTH conjugate. If only both are present, but if only RL is variable, then RL will be under root of RTH square plus XL plus XTH whole square. Remember that condition. If an AC circuit, but the load is purely resistive, then again remember the condition mod of ZTH under root of, and remember those conditions. Actually, that's what I want to tell you. Let's move on to the next question. Let's see the next question. This is the next question that we have. Just think about it for 10 seconds. BPN motivational. Sir, love you. I love you too as a student. Okay. Good. Few students gave the answer correctly. Balu Krishna and Kapil, excellent. You gave 0 as the answer. Really good. Good question, sir. Thank you, Aparna. Akash Tiwari, your link is not working. Akash, I don't know, everybody is able to see that, please refresh. Okay. Okay, let's solve the question. I hope सोच लिया होगा. चलिए देखते हैं. It's saying that for what value of resistance R, the steady state energy stored in the inductor will be 1 joule. Resistor R की किस value के लिए inductor में जो steady state energy stored है वो 1 joule होगी. See, it's a transient question, but not a straightforward question, a little bit twisted question. Language में घुमा दिया उसने. अगर आप step by step चलेंगे आप question solve कर लेंगे. And remember this point as an advice from me when you're solving the gate examination 2 marks question. जब भी question पढ़ते हैं ना तो ऐसा नहीं होता कि पढ़ लिया और आंसर समझ में आ गया. कई बार होता है tough question होते हैं. Just think about a blueprint that what is asked, whatever is asked, how will I approach this? Okay, these are the methods that I can think of right now for approaching this final answer. Now, for these methods, what is the information that I need and what kind of information is provided in the question? Approach it like that. Backward process of flow sometimes help you to solve the question. For example, in this question, he is asking you for what value of resistance R, the steady state energy stored in the inductor will be 1 joule. Which energy he is talking about? Steady state energy. It means if I'll be able to calculate the steady state energy in this, then I think somehow I'll get the answer for this one because that will be the only unknown variable I'll be having. Fine. What is the steady state energy? Steady state energy, I can use the formula half Li square, and I square there will be I infinity square. It means I need the steady state current flowing through the inductor. That's it. So let's solve the question. So at t equal to infinity, okay, at t equal to infinity, the steady state, this will be short, okay, because for the DC source under steady state condition, inductor acts as a short circuit. Therefore, this is what I'll be having: 60 volts, 40 R, inductor replaced by a short circuit, 80 ohms. So this is the steady state circuit that I'll be having. 40 ohms, R unknown, 80 ohms, inductor we have replaced by a short circuit. This is the current I'm interested in calculating. So let's solve this current value. How can you approach this? I'm going with the nodal. Let's say this node voltage is Vx. So you can say this will be Vx minus 60 divided by 40 plus Vx divided by 80 plus Vx divided by R is equal to 0. Okay, Vx minus 60 by 40, Vx by 80, Vx by R is equal to 0. Let's take the LCM. What would be the LCM that I'll be having? 80R. So if 80R is there, so 2R, so it will be 2R Vx minus 2R, so minus 120R plus 80R, so it will be only Vx into R plus 80R, so it will be only 80 Vx is equal to 0. If we simplify this one and we want to find Vx, so let's take Vx common. So what I'm left with is 2R Vx plus R plus 80 is equal to 120R on the other side. Therefore, Vx is coming equal to 120R divided by 3R plus 80. So this is the Vx value that I have got, but what I am interested in calculating I infinity, because we are doing the calculation at infinity. So you can see the steady state value of the current will be Vx divided by R, which is coming as, if I divide it by R, it will be 120 divided by 3R plus 80. So this is the current value that we have got over here. I infinity I have calculated. So now let's go with the steady state energy. So the steady state energy stored in the inductor will be half L. Formula क्या होता है standard? I square infinity minus I square T naught जहाँ से start की हमने value. मतलब यहाँ bracket डलेगी, क्या आएगा? I square final value, क्योंकि final निकाल रहे हैं, minus जहाँ से start किया. Start T equal to 0 से किया था, हम मान के चल रहे हैं, inductor unenergized था, कुछ नहीं बताया, तो वो 0 हो जाएगा. So this is what I am having. What is WL infinity? In the question he has mentioned it is 1. So 1 will be equal to half, inductor is of 2 Henry value, 2 Henry, I infinity square, so it will be 120 divided by 3R plus 80 whole square. I hope you can do the calculation on your own, it's just wasted of time. Square 1, so 120 will be equal to 3R plus 80, or you can see R will be equal to 40 by 3, that should be equal to 13.33 ohms. Okay, so answer आप निकाल लेंगे, but the thing is that the concept is important, how to handle this kind of questions. Transient question था, simple था, सिर्फ final value के साथ deal करना था, we can go step by step. Okay, चलिए अगला question देखते हैं. This is the next question that we have. जल्दी से सोचेंगे, 10 सेकंड लेंगे सिर्फ, फिर आगे चलते हैं. चलिए देखेंगे. So this is the next question that we have over here. He wants us to calculate Vc of t for t greater than 0. देखो बच्चा, मैं एक चीज categorically बोलना चाहता हूँ. There are two ways to solve the transient question that we have learnt in the class. कौन कौन से दो तरीके हैं? The first one is the generalized formula for DC and UT. The other one is the Laplace application of Laplace transform. Okay, दोनों use कर सकते हैं. If you get this kind of question and suppose you are unable, you are not comfortable with the basic or the shortcut formula that we have learned, go with the Laplace. Laplace will obviously take a little bit more time, as I told you in the class also, but you will get your answer eventually. So even if you waste 30 more seconds but you get your answer correctly for a 2 marks question, it's worth. But I'll advise you to go with the shortcut when DC is there, but if somehow you are struck, then use the other formula, Laplace technique. Let's see this question. Why, sir, what's the difference in this question? 3 capacitors. And I don't know why students are always uncomfortable with these kind of questions. So they quickly jump to Laplace. It's okay, but still, how to handle this kind of question, have a look. What I'm thinking that if I can calculate the voltage across this combination of these capacitors, ये तीन series में है, I can combine it into a single capacitor, and if you calculate the voltage across that combination, then by using the voltage division rule we can calculate Vc, not a big deal. Okay, so what I'm going to do, I'm going to replace it by a single capacitor, that is C equivalent. This is what we have. Okay. What will be C equivalent? Series 1 by C equivalent will be equal to 1 by 1 micro plus 1 by 2 micro plus 1 by 3 micro. This will be equal to, taking 6 micro as the LCM, so this will be 6 plus 3 plus 2 divided by 6 micro. So 6, 3, 9, 10, 11 by 6 micro, or you can see the equivalent capacitance is coming as 6 by 11 microfarad. So this is the equivalent capacitance that we have calculated from here. Okay, so this is the equivalent capacitance we have calculated. First task over. Now the question has got changed from this to this. In this question, I want to find the voltage across this capacitor combination. Because once I have the voltage across this combination, that is as good as saying that I have the voltage across this, that is this. So I can later on use the voltage division to get my answer. That's what I'm thinking to do over here. So now, let's start solving this question. So what will be the first step? The first step is always the initial conditions, that is just before operating the switch, what was the voltage of the capacitor? So let's do it. That is at t equal to 0 minus, because at t equal to 0 we have operated the switch. Now at t equal to 0 minus, a DC source is there, the circuit will be in steady state, so I can replace the capacitor by an open circuit. That's what I have done over here. So now I want the voltage V, apply the voltage division rule, I'll get my answer. So you can see the voltage V, this will be equal to 9 divided by 1K plus 4.7K multiplied by, because 9, sum of these two multiplied by 4.7K. And if you solve this, I think this should be 7.421 volts as the value. Okay, so this is the initial voltage you're getting for this capacitor combination, that is V0 plus, which is same as V0 minus. This is coming as 7.421 volts. First step, first task over. We have calculated the initial conditions for the capacitor. Now what is the next step? Next step is to develop the circuit after the switching. That is, let's develop the circuit for t greater than 0. So for t greater than 0, the switch is opened, only this part I have. Okay, only this part I have. After this we have to check whether it is with source or without source. As you can easily notice, it is without source. So what will be the capacitor voltage? V, okay, Vc I have taken later on, so let's write Vc only over here. So Vc of t, this will be equal to V naught e to the power minus t by tau. V naught we have already calculated, 7.421. Now next we need is the time constant. Time constant will be R into C equivalent. Resistance is 4.7K into C equivalent, that was 6 by 11, let me check, 6 by 11 microfarad. 6 by 11 microfarad. So if we solve this, we will get the value as 1 by 390 seconds. So this is a time constant. Let's substitute the whole information in this. So you can see VCT will be 7.421 e to the power minus 390 t volts as our answer. Okay, but what we are interested is in calculating this. And see, I have seen this thing sometimes how they will frame the answer. Option A, B, C, D. The A option will be this, 7.421 e to the power minus 390 t. What happens basically, we are in so much hurry that while solving the question we forget that what was the main question. We get the VCT value and we think that's what we were solving. We see the option also in the exam and we get very confident that's what I wanted to calculate, and you mark option A and you move on. So please be careful what you are calculating. हमेशा टिक करने से पहले एक बार देख लेना पूछा क्या था, ये निकाल दिया है, टिक कर देंगे. जब हम क्वेश्चन में वापस जाएंगे और हम देखेंगे पूछा क्या था, ये निकाल दिया है, नहीं तो ये निकालते हैं. So let's go for the voltage division rule. I hope you do remember when we were studying in the class, I told you when more than two capacitors are connected in series, how to apply the voltage division rule, because students only know for two capacitors. More than two, they do not know. So let's utilize that concept over here. So you can see, okay, let me check. VC, okay, it's only a matter of variable, nobody is going to see what we're doing. But variable VC was there in the question. So we have solved only V up to now, okay. Let's keep it V only. It's only a change of variable actually. When we are solving the objective paper, nobody is going to see what we have done over there in the exam. So we have calculated VC until now. So V we have calculated, VC what we are interested in calculating. So let's move on. So I'm applying the voltage division rule. VCT, this will be equal to V of t divided by, क्या फॉर्मूला लगाते थे हम, 1 by C1 plus 1 by C2. So 1 by C1 plus 1 by C2 plus 1 by C3 and so on, multiplied by 1 by, जिसके across पे निकाल रहे हैं, we are calculating across capacitor 2, so I'll be writing 1 by C2, that is 1 by 2 micro. You put this value over here and do the calculation. Let me see whether I have the answer or not. Yes, I have the answer for this one. If you solve this, this is coming equal to 2.024 e to the power minus 390 t volts. This is my answer. So this is VC of t. So it was a good question. Firstly, when more than one capacitor, more than one capacitor connected in series, how to handle that kind of equation? Go for the C equivalent, then you can go for the expansion. And the voltage division rule when more than two capacitors are connected in series. Let's move on to the next question. Take your time, have a look. BPN, thank you so much for your nice words. Thank you. Pratmesh, I learned control from you. Good to see you again, sir. Thank you. Good. Okay, quickly see this question because there is one twist in this question. Quickly see this. Take 10 seconds. I'm going to solve this then. I hope बच्चा आपने सोच लिया होगा कैसे solve करना है. Let's do it now. So now we want to solve this question. We want to find the VCT for all time t. That's what he wants us to calculate. If you see, two different sources are there. Actually, it's a double switching questions that we did in the class. Okay. If you see 40 UT, 40 UT किसके बराबर है? 40 UT is equal to 40 for t greater than 0 and 0 for t less than 0. It means this source will get activated at t equal to 0. उससे पहले ये नहीं होगा. Next, 100 u of t minus 1. 100 u of t minus 1 will be 100 volts for t greater than 1 and 0 for t less than 1. इसका मतलब ये 1 सेकेंड पे एक्टिवेट होगा तो दो बार ट्रांजिएंट दिख रहे हैं. पहले सर्किट नॉर्मल पड़ा होगा, at t equal to 0 40 volt आएगा, a transients will be there in the circuit, and then again circuit will be going towards steady state, then again at t equal to 1 second again a change will be there and the transients will be there. Double switching cases there. So quickly solve this question, जल्दी जल्दी देखेंगे. So the first step will be to develop the circuit, okay, and see what was there for t 0 to 1, because first I am going to solve for t greater than 0 less than 1. For that initially if you see, neither this was there nor this was there. The circuit was initially unenergized. I can easily conclude that Vc0 plus, which is equal to Vc0 minus, this was equal to 0 volts. The circuit was initially unenergized. Now, let's go for circuit for t greater than 0 less than 1. So for t greater than 0, 40 volt is activated, but still 100 volt is not there. So the value of 100 volt is 0. So if a voltage source value is 0, can I replace it by a short circuit? That's what I have done over here. This is the circuit that I have now. Okay. Now, what will be the Vc value? So Vc, as it is a with source case, so Vct will be equal to final value plus initial value minus final value e to the power minus t by tau. So this is the capacitor voltage value, final plus initial minus final e to the power minus t by tau. Initial we have already calculated. Now we are interested in calculating the tau and the final value. So let's go for the final value. When we go for the final value in the steady state for the DC source, it will be replaced by an open circuit. So let's replace it by an open circuit, that is at t equal to infinity. So at t equal to infinity, this is the circuit that we will be having, capacitor open. Now can you see this branch and this branch, they all are connected in parallel. ये तो open है, हटा दो इसको, तो आप देखो तीनों branches parallel में हैं. It means the voltage across this whole branch will be 40. By using voltage division, whatever voltage will be across 20, the same will be Vc. So let's go for voltage division. So Vc will be equal to 40 divided by 5k plus 20k multiplied by 20k, which can be further written as 40 multiplied by 20 divided by 25, k cancel हो गया, which can be further written as 5, 4, 8, 32. तो हमने फाइनल वैल्यू निकाल ली. अब क्या चाहिए हमें? टाइम कांस्टेंट. टाइम कांस्टेंट निकालने के लिए कैपेसिटर के टर्मिनल्स के बीच में देखेंगे, इसको शॉर्ट कर देंगे. सो वी आर कैलकुलेटिंग आर इक्विवेलेंट फॉर द टाइम कांस्टेंट. दिस इज व्हाट वी हैव. ओके, सॉल्व करना है. मैंने आपको बताया हुआ है, जब भी सामने सामने ना दिखे पॉइंट्स मार्क करो, इजीएस्ट वे है करने का. बी बी, दिस इज बी, बी बी, दिस इज बी, दिस इज ए. Can you see that 10k is connected between B and B? If any element has both the terminals, if any element has same terminals, then it means it is a short. Because ये 10 तभी short है, देखो ना ये पूरा short हो रखा है, ये इसके parallel में है ना, short इसके parallel में placed है, तो ये dummy हो गया. Between A and B, these two are in parallel, and between A and B we are calculating R equivalent. So you can see R equivalent will be 5k connected in parallel with 20k. That will be 100 by 25, 4 kilo ohms. Therefore, the time constant, which is R equivalent into C, is coming as 4k multiplied by 0.1 milli. 0.1 milli. Hence, the time constant is coming as k milli, 0.4 seconds. Let's put all the information that we have in this formula. So you can see Vct is coming as final value 32 plus initial value 0 minus final value 32, common ले लिया, e to the power minus t by tau, which is 0.4. Okay, so this is the voltage that we have got, but this relation is between 0 to 1 because 1 के बाद दोबारा चेंज होगा सर्किट, क्यों? 100 वोल्ट एक्टिवेट होने लगा है। तो जब सर्किट 1 के बाद दोबारा स्टार्ट होगा, we will be needing the initial value, that is at t equal to 1 plus, which we calculate from here. So what will be Vc1, put 1 second in this expression, and this will be equal to, I have already calculated this one, let me check what is the value for this one that we are getting. We are getting 29.37 volts. So this is 29.37 volts. So initial value we have calculated, that is Vc1 plus will be same as Vc1, which is same as Vc1 minus, which is coming as 29.37 volts. अगले स्टेप के लिए इनिशियल वैल्यू निकल गई. सो आई होप यू रिमेंबर डबल स्विचिंग क्वेश्चन, स्टेप बाय स्टेप चलते थे हम लोग. नाउ नेक्स्ट विल बी टू डेवलप द सर्किट फॉर t greater than 1. अब क्या होगा बच्चा? लेट्स हैव अ लुक ओवर हियर. ये तो एक्टिवेट हो चुका था 0 पे, अब 1 सेकंड के बाद ये भी एक्टिवेट हो जाएगा. ये तो एक्टिवेटेड है क्योंकि अब ये 0 टू इंफिनिटी जाएगा, बट दिस विल आल्सो गेट एक्टिवेटेड नाउ. सो what is the circuit that we will be having this time? So for t greater than 1, this is the circuit that I'll be having, both the sources now activated. So now what will be Vc of t? Let's write the formula for this. So you can see Vc of t will be final value plus initial will be Vc1 plus minus final value e to the power minus, circuit is delayed by 1 second, so t minus 1 now. Initial we have already calculated, now we are interested in calculating the final value and the time constant. So for final value, that is at t equal to infinity, at t equal to infinity, this is the circuit that I will be having. Okay. So see, without wasting a lot of time in the calculation, actually it's just an application of the nodal now. Let's apply the nodal now. Vc minus 40 by 5k. Okay, let me write actually. So equations you can solve Vc minus 40 divided by 5k, because this is what I am interested in calculating. So Vc minus 40 by 5k plus Vc minus 100 divided by 20k is equal to 0. Let me check what is the answer. I won't be calculating, it will be taking a lot of time. So it is coming as 52 volts. It is coming as 52 volts. Final value we have calculated, initial we have calculated. Now let's calculate the time constant. So time constant again will be R equivalent into C. Okay. So short, this is open, and we'll be calculating this. So the same situation like this. Short, open, the same situation, tau will be same, R equivalent into C, and then we can finally solve that, putting the values in that. So let me see what is the answer that we are getting, okay, because time constant will be same 0.4 second. So final answer will be 52 minus 22.63 e to the power minus 2.5, 0.4 को लिख दिया है, into t minus 1. ओके बच्चा, क्योंकि फाइनल वैल्यू प्लस इनिशियल माइनस फाइनल मैंने कर दिया ऑलरेडी, ये आ गया है e टू द पावर माइनस t by 1 डिवाइड बाई टाउ. टाउ वाज 0.4, 0.4 को लिख सकते हैं 4 by 10, 10 by 4 will be 2.5. So this is our answer. So calculations you can handle. The only thing I wanted to show you is that a double switching question. Already we did this kind of questions in the class, but I wanted to emphasize it because in this we solved 2 transient question, good practice, and another way of giving a double switching case. Just take 5 seconds, have a look, then I'll show you the next question. I hope बच्चा हो गया होगा. This is the next question that we have. Okay, again the transient question. See, if you can directly apply the shortcut concept, good. If you are somehow not comfortable or having any kind of doubt, then you can go with the Laplace transform also. So let's see with the Laplace transform. A few students are writing few things. Okay. Two put question, see, I don't think I'll be having time left with that, because I can only deal with important questions. And have means if you have are a medicine student, then I think I shouldn't be doing two put questions. It will be wastage of time. But not very difficult questions they're going to ask in two put. If you can calculate parameters either with the equation method or with the short circuit and open circuit method, you will get your answer. But the topics which are difficult, you find difficulty in transients and all those things I'm touching, because in this much time the most important topics I'm covering. Okay, because again then you will ask about magnetic circuits, dot polarity questions. Everything can't be done over here. So whatever is important, I'm trying to cover as much as I can actually. So have a look quickly over here. This question can be either solved with the help of the Laplace or with the normal method. Normally you're not comfortable, so let me show you with the Laplace, then we will go with the normal method also. Laplace, what are you going to do? First step, initial condition. Initially the switch was open and initial initial value of the capacitors given. On this the voltage was 2 volt, on this the voltage was 0 volt. What is the next step? Next step is develop the circuit after the switching, because मैंने आपको ये specifically बताया हुआ है कि कोई भी question हो transients का, be it initial condition question if you are applying the Laplace transform or you are applying the shortcut technique, no matter what type of question you are dealing in the transients, initial conditions you always have to calculate first. There is no escaping from that. They have given, if they haven't given that, then you have to calculate it. So for t greater than 0, what will be the circuit that I will be having? Switch will be closed. This is the circuit that we will be having. T greater than 0, switch closed. This is what I have. Now, apply the shortcut method if you can. We will be seeing it very soon. But now, after this, if I am thinking about going with the Laplace, then what we say? Transform the circuit from time domain to the Laplace domain. I hope वो याद होगा. कैपेसिटर के साथ हम एक वोल्टेज सोर्स सीरीज में लगा सकते हैं और करंट सोर्स पैरेलल में लगा सकते हैं. सेम इज द इंडक्टर आल्सो इन द वैल्यू एंड करंट डायरेक्शन एंड द polarities we have to take care of. So when we do that, I am connecting a voltage source in series with a capacitor. What is the value of that? Vc0 plus divided by S. 1 by S, the voltage initially was 2, so Vc0 plus by 0 plus divided by S, that is 2 by S. 1 by S, initial voltage was 0, so short. This is the circuit that we have. Let's solve this to get the answer. I of S, this will be equal to voltage 2 by S divided by 1 by S plus 1 by S. Can write it as 2 by S plus 1 by 2. This can be written as 2 by S divided by 4 plus S divided by 2S. Okay, because 2, 4, S, 2S aa jayega. It will go in the numerator, S and S will get cancelled. So what I am left with is 4 divided by 4 plus S. So if we take the inverse Laplace transform, I of t is coming as 4 e to the power minus 4 t ampere. Task over. Or we could have even solved it with the help of the shortcut method. I know you must be curious, sir, कैसे handle करेंगे? Doubt है यहाँ पे. बहुत आसान है वो भी. देखते कैसे handle करते. अगर आपको इसकी करंट निकालनी है शॉर्टकट मेथड से, so you know that the current I of t will be I naught into e to the power minus t by tau, because after closing the switch it will be a source free circuit. So this is what I am writing. Tau will be the time constant. Of course I can handle that, no problem, we can calculate it. I naught, how to calculate the I naught? Because I cannot say the current at t equal to 0 minus in the capacitor, the same will be at t equal to 0 plus. How are you going to do that? We are going to use the concept of the initial condition questions. That is, let's, second method, okay, let me change the pen color. Let's do the calculation at t equal to 0 plus. I naught is the current through the capacitor at t equal to 0 plus. So find the current at t equal to 0 plus only. So how to do that? You know that when we are doing the calculation at an instant of time, at that time capacitor is not going to allow its voltage to change. It means I can replace the capacitor by a voltage source. Therefore, let me replace capacitor 1 by 2 volt, capacitor 2 by 0 volt. First capacitor by 2 volt, second by 0 volt, because at an instant of time it is not going to allow its voltage to change. So from here you can see I, because you can say I also the current to the capacitor also you can say. So I will be equal to 2 divided by 1 by 2, so the current is coming as 4 ampere. So initial current, that is at t equal to 0 plus, which is obviously we have written as I naught, I have calculated. The next thing I am interested is calculating the time constant. So sorry, this is the circuit that we have. From here, can you handle the time constant concept? Yes, very easily we can handle the time constant. How? Tau will be R into C. What is the resistance? 1 by 2. What is the equivalent capacitance? Because the resistance will be between the terminals of the equivalent capacitance. Equivalent capacitance means 1 and 1 connected in series. Can I write it as 1 by 2, which will be 1 by 4 seconds. Substitute in the main formula, IT will be equal to I naught. I naught we have calculated as 4 e to the power minus t by tau, that is 4 t ampere. Same answer. Okay, so that's how you can handle this kind of question. You can go with the Laplace also if you are comfortable with that. Let's see the next question. Quickly have a look, then we will solve this. I hope question देख लिया होगा. चलिए बच्चे यहाँ देखिए. The first thing that I want to notice over here is that this is a bridge. Although I have already told you in the class, but still. इसको आइडेंटिफाई करना है, मिस नहीं करना है. पहले भी दिखा चुका हूँ ब्रिज वाला, वो ब्रिज घुमा फिरा के देते हैं. You should be able to identify the bridge. So this is a bridge that we have over here. Fine. Sir, so what? You know that if it's a bridge, central arm, the bridge is not balanced. Okay. If the bridge is not balanced, then what I should be doing? Star delta transformation. No other method that we have. Okay. Meaning, if sir I can go with the mesh and all those things, of course, but I'm going with the equivalent concept, that will be easy. Star delta we want to go. So I'm going delta to star, sorry, I'm going for this delta to star. Because you know that every edge will be connected and this will be neutral. Let's say this is A, B, C, and let's go for the formula. So this is what I'll be having. Okay, this is from here, this point, and this point. So when I do that, from this point to neutral, I'll be having ZA, then this point to neutral ZB, this point to neutral ZC. This is what I'll be having. ठीक है बच्चा, समझ में आ गया? आप ध्यान से कंपेयर कर लीजिए. ZA से न्यूट्रल, A से N के बीच में ZA कनेक्ट किया हमने. From N to point B, I have ZB. From N to point C, I have ZC. What I need is the value of ZA, ZB and ZC. I hope you know the formulas. मैं एक लिख देता हूँ, but otherwise it's wastage of time. What will be ZA? ZA will be this into this, that is minus J2 into 4 divided by, इस पूरे का sum minus J2 plus 4 plus J6. And we can solve all these ZA, ZB and ZC values. I have those values. Let me tell you what are the values. ZA is minus 1 minus J1, minus 1 minus J1. ZB is 1.5 minus J1.5, 1.5 minus J1.5, and ZC is coming as 3 plus J3, 3 plus J3 ohms. So we have ZA, ZB and ZC. Now we have calculated ZA, ZB and ZC. Now we are over here. What we are interested is in calculating I naught. I hope you can do the calculation now. तो सिर्फ कैलकुलेशन करनी है, it will be wastage of time if I'll be wasting, because now the equivalent impedance I want to find out. Series, parallel, series, you have Z equivalent. So when you calculate Z equivalent, because calculation you can do, it will be wastage of time if I'll be doing all these things. Z equivalent finally will be having 6.76 at an angle of minus 8.33 degrees ohms. This will be Z equivalent that I'll be having, and then finally I naught, which will be voltage upon Z equivalent. I naught value we have 8.874 at an angle of minus 21.67 degree ampere. The final answers are just for your satisfaction, that when you solve you should be able to see the answers finally. That's it. Okay, so I hope you copy कर लिया होगा. This is the next question. जल्दी से देखेंगे, जल्दी से सोचेंगे इसके बारे में क्या करना है. Quickly see it. चलिए, concept is important. I won't be solving because already we have taken a lot of time. So concept जल्दी देखेंगे इस question का. See, you cannot apply any method for solving this question instead of what? Superposition theorem. Why I'm so confident about this fact is frequency. In the first case the frequency is 2, and in the second case the frequency is 6. Different frequencies, so at different frequencies the reactance will be different. Therefore, we have to solve the circuit one by one by applying the superposition theorem. So concept is important, that's it. Answer I'll give you. So first let's activate the first source, that is the current source. So at the current source frequency is 6 into 530, so it will be J30 Vx dash current division, and you will get your answer. Let me tell you the answer actually. I have the answer for this quickly, let's go for it. So when you solve this, you can go with the current division or you can go with the impedance, whatever method you want to apply, it's okay. So in the first case Vx dash, this will be equal to 147.7 cos of 60 plus 26.5 degrees volts. Now similarly in the second case, when we will activate this source, I'll be having 2 as the frequency, so 2 into 5, it will be J10 now. Have a look. This is the same circuit for calculating the equivalent value. This is the circuit that I was talking about. Sorry. Now this will be J10 Vx dash, simple voltage division formula, and now in this case the Vx double dash value, it is coming as, do I have the answer for this one? Yes, 21.41 sine of 2t minus 15.52 degrees volt. So this is what we have as Vx double dash. So the total answer Vx, this will be Vx dash plus Vx double dash. So the only thing I wanted to show you is this: when you have two different frequency components, please be careful to apply the superposition theorem. Okay, now let's see one more thing. Do we have some other question? No, we do not have any question. So let me show you one question actually. Let me frame the question. Values can be incorrect, but the only thing is that I want to show you a question. While teaching, I was thinking about dealing with this question. Let's frame a question very quickly. Let's see what we get. Let's take it as 1 ohm, 1 ampere, Ix, and 1 1 and let's say 2Ix. I'm giving you 30 seconds. Quickly calculate the Thevenin resistance for this question between the terminals A and B. Quickly do it. Calculate RTH. Find it. Quickly do it. चलिए कुछ तो किया होगा आप लोगों ने. यहाँ देखते हैं. What's different about this question? Let's first calculate VTH. Okay? सर आपने तो RTH कहा था. हाँ, RTH के बाद कैलकुलेट कर रहे हैं. Let's go for VTH first. इन टर्मिनल्स के बीच में जो वोल्टेज नजर आएगी वो क्या हो जाएगी? VTH. Okay, I hope you can do the calculations on your own. Let me tell you the concept actually. It will be wastage of time if I'll be doing the calculation for this question. See over here, if I calculate the RTH which I asked you to calculate, okay, RTH if I want to calculate between these two terminals, I'll be deactivating all the independent sources, open, and then you will say I have a dependent source, so I'll be connecting either a voltage source or a current source to solve this question. Fine, but please carefully observe one point. If you apply the KCL at this point, Ix is coming equal to 2Ix. Is this possible? I hope you can understand. ये possible नहीं है. इसका मतलब अगर आपने RTH निकालने के लिए इसको डीएक्टिवेट किया तो सर्किट ही पॉसिबल नहीं रहेगा. So how to handle now? What to do now? So in this kind of question, when you get stuck in this kind of situation actually, okay, this is the question that I made, values I don't know what's going to come, but if you get struck, you know, you face this kind of problem in the examination, you are calculating RTH, after deactivating you open circuited or short circuited something, and suddenly the KCL or KVL got violated after that. Then for calculating RTH, or as a matter of fact Rn also, go with VTH by In. That is, in this question calculate VTH, then calculate I Norton, and then go for VTH by In, and you will get your answer. Okay, so this is the kind of a question I thought, that's why I thought of telling you. Let's finish our discussion because I have already taken a lot of time. Let's finish our discussion with one MSQ. Let's make one MSQ. Let me frame the question, okay? The voltage across some element is suppose is 60 cos of 2t minus 60 degree volts, and the current flowing through the element in the direction of the voltage drop, what I want to say that the element is a load, okay, is 10 cos of 2t minus 10 degree ampere. Then ये सुनना है बस समझाने के लिए, then the circuit or the element can be realized, that can be realized by A option RL, B option RC, C option LC, D option RLC. ओके, तो हम किससे रियलाइज कर सकते हैं? एक एलिमेंट को जिसके अक्रॉस, यहाँ दो एलिमेंट बना हुआ किसी से, इंपीडेंस है जिसके अक्रॉस ये वोल्टेज और करंट है, जिसके थ्रू करंट है, वोल्टेज उसके अक्रॉस है. And it's an MSQ, multiple choice, multiple select question actually. So what I'll be doing, I'll be first calculating the impedance value. That will be V by I. Voltage, I can write it as 60 at an angle of minus 60 degrees, sir, RMS, obviously it's going to get root 2 is going to get cancelled for impedance, and I'm writing it in the phasor form. So 60 at an angle of minus 60 degree divided by 10 at an angle of minus 10 degrees. Okay, if we solve this, this is coming as 60 by 10, that is 6 at an angle of minus 60 plus 10, minus 50 degree ohms. The first thing I can straightforward conclude, this is not possible, because the angle is obviously between 0 to 90 or 0 to minus 90 or from minus 90 to plus 90, between that and not 0. So obviously it should be having a R component along with RL or RC, something R should be there, so it's not possible, because in this case minus 90 plus 90 is going to come. So coming back, okay, so this is the impedance I am getting. Impedance angle is negative. It will be in case of capacitor or in case of inductor. It will be in case of capacitor. I can rule this out. So sir, I can form it with the help of R and C, because if I expand this, some positive term minus some negative term, so obviously R minus JXE, this should be the answer. It seems this should be the answer, but he has said that can. It can be realized by this also, and it can be realized by this also, isn't it? Because here X can be XL minus XE, where magnitude of XE is greater than magnitude of XL. The same situation I will be left with. It will be R plus J XL minus XE, XE is greater than XL, so I will be having some negative value, the same thing. It means both of these options are correct. So it can be realized either by this or by this. Got the point? So this was all from my side, because whatever time I had, I tried to give you the most important concepts that can be asked in the examination, because a lot of time these concepts have been asked in the exam. And those having this kind of feelings are two ports or dot polarity and other topics, see, means I had a limited time and I covered as much as I can. So best of luck for your GATE examination. I wish something come from this, or if you are made as a student, then everything will be from the examination point of view. One thing I want you to do, go through the locus diagram question also. If you are made as a student, we have already done it in the class, no need. If you're not a made as a student, then do one thing, or you have studied on your own. What I'm trying to tell you is that you must be having made as the previous year GATE book, in which all the solutions are there. So in that you will find 2-3 locus diagram questions that have been asked in the past examinations. Just go through the solution at the end. That will be more than sufficient to get a hang of locus diagram question, because not very often, maybe after 7 years, 6 years, they ask one question. So why not to go through it, because that is the kind of a question which students normally tend to leave. Rest important thing, I have already covered the topics which are important from the examination point of view. So all the best of luck for your exam. I hope you all clear the examination. Take care.